Well, hello. Okay, we are going to do 11.4 today. So let me get what I need here. All right, 11.4. All right, 11.4 deals with certain properties of logarithms. So we need to understand how we can expand or shrink logarithms, okay? Now, if you have a log where you have two things that are being multiplied, it is the same as the first thing plus the second thing. Look what I did. These two are being multiplied. Now they're here, and they're separated by addition. Likewise, if you have something that's being divided, it's the same as the numerator minus the denominator. Two things being divided, numerator, denominator, separated by subtraction. Okay? And the last property is if you have something that's raised a power, the raised goes on the outside and it's multiplied by, so this goes on the outside. It's whatever it is times the log. Okay? Now with that said, if I had log base 5 of 6 times 9, that could be rewritten as log base 5 of 6 and log base 5 of 9 separated by addition. Or what if I had log 7, 8 plus log base 7, 12? I could put those together and say it's log base 7 of 8 times 12, or log base 7 of 96, because we could multiply those. This could be log base 5 of 54. Okay? One other, just example, what if I had log base 3 of 3x? How could we expand it? Log base 3 of 3 plus log base 3 of x. Now this is going to be important because we're going to have things where we have to solve for x. So that's why we need to know how to do this, okay? So what if I had, and that was when they're being multiplied. Let's practice a couple when they're being divided. What if I had log base 4 of 7/9? That would be log base 4 of 7 minus log base 4 of 9, okay? Or if I had long ways, what if it was log base 5 of 6 minus log base 5 of x? Shrink that up, it becomes log base 5 of 6 divided by x. Okay? And the last property was, what if I had this, 4 squared? That becomes 2 times log base 5 of 4. Same thing, log base of x to the 5th would be 5 times log base b of x. Okay? And then they try to throw one in there to trick you. What if it was log base 2 of the 5th root of x squared? Well, first of all, you need to know and remember that you can rewrite this as x to the 2/5. That's the numerator, that's the denominator, which then could become 2/5 times log base 2 of x. So whenever you see a radical, remember to turn it into a fractional exponent, and then you can do stuff with it. Okay? All right. Let's try a bigger one. Let's try a more complicated one. What if I had 4 times log base b of m minus log base b of n? And I want you to shrink it. Well, notice I showed you multiplication first, then I showed you division, then I showed you how to raise the power. So when you're shrinking it, go backwards. Do the raising of the power, then do any division or multiplication. Okay? So the first thing I'm going to do is make this log base b of m to the 4th minus log base b of n, which now means all I have is division. So m to the 4th is the first, so it's the numerator, and n is the denominator. All right? Let's look at a big one. Log base b of x plus 1 plus log base b of 2x plus 1 minus 2/3 log base b of x. Take care of exponents first. So I'm just going to rewrite this. Base b of 2x plus 1 minus log base b of x to the 2/3. Now, go from left to right. This is addition, so what do we do to these? We multiply. And this is subtraction, so what do I do with this? I divide it. Now, we're just shrinking it or expanding it, okay? Now, then they give you a short little application to make sure that you know what you're doing, and you can see in a small way how we could do something with this. We do more than that, but this is just an introduction, okay? So this is to get you started. What if I told you log base 2 of 5 was equal to 2.3219, and log base 2 of 3 is equal to 1.5850? And they wanted you to solve for log base 2 of 15 or log base 2 of 27. Well, I got a 5 and I got a 3. I got to figure out how I can expand 15 to be 5 and 3. Well, isn't this 5 times 3? Which means it would be log base 2 of 5 plus log base 2 of 3. What is log base 2 of 5? 2.3219. What is log base 2 of 3? 1.5850. So, when you add that together, you get, hang on, I gotta get my calculator out here, 2.3219 plus 1.5850 gives me 3.9069. Answer. Okay, what do we do with 27? Do you see 5 in 27 at all? I don't, but I see 3. I actually could rewrite this as log base 2 of 3 cubed. 3 times 3 is 9 times 3 is 27. All right, what do we do with that? That becomes 3 times log base 2 of 3. All right, 3 times, what is log base 2 of 3? 1.5850. So 1.5850 times 3 is 4.755. And there's your answer. They're going to give you these kinds of things and have you try them out. Okay? So you could practice the whole expanding and or shrinking. All right, that's 11.4. Now, are logarithms scary so far? Nope, not so much. They're just something that was difficult to understand at first. All right. In 11.5, they require you to use your calculator. They want you to find log of 5, or log of 8, or log of 6.1, or ln of 5, or ln of 6, or ln of 8. Okay? When they don't put a base down here, it means it's base 10. For logarithms, when they don't put a base, you know how if you say x plus 3, you really know it's 1x? It's like invisible. Well, when they don't put a number for a log, it's base 10. And that is what your calculator is set at. So in order to find log base 10 of 5 or log of 5, you got to find the button that says this. Now, for some calculators, you put in the number 5, and then you push the button log, and then you push equals, and you get an answer. For some calculators, you push log first, then you push 5, and then it just shows up, or you might have to push equals. You're going to have to figure out with your own calculator which works, okay? Now, that's for logs, but what is this, ln? Well, first of all, the base in an ln is always e. It's never anything else, so they don't write it. But besides a log button, if you have ln of 5, you need to look for the button that says ln, and you do the same thing. Sometimes you have to put ln, then the number 5, and then equals. Sometimes you have to put number 5, then ln, and then the number equals. You need to figure it out. But 11.5 is you learning how to use your calculator. And then one more little thing, okay? What if I wanted you to find that? That's not base 10. You can't put log 2 in your calculator. It's only if it's base 10. So how do we do it if it's not base 10? Well, there is something called change of base formula. And it looks like this. Whatever you have, you can put it in your calculator by taking log of this number in base 10 divided by log of that number in base 10. It's basically, you're doing this. You're just dividing, okay? So if that were the case, log base 5 of 2 would be log base 10 of 2 divided by log base 10 of 5, and then you'd have your answer. And what's really interesting is you could also do ln of 2 divided by ln of 5. You don't have to use log 10. You can use your ln. You'll come up with the same answer. I just always, if I'm in log, I stay in log, okay? But you could, it actually works both ways because it's a ratio. And whether you're using the basic logarithm or the natural logarithm, they all have the same ratio, so it's going to come out the same, okay? But that's for change of base formula. So if I had log base 3 of 12 to get the answer, I'd have log base 10 of 12 divided by log base 10 of 3. If I had log base 3, the square root of 2, I'd have log base 10 of the square root of 2 over log base 10 of 3. Whatever it is, you just divide that to get an answer, okay? All right, that's 11.5. Now, 11.6, I'm going to record separately because it's a good one. It's a long one, okay? So that's all of 11.4 and 11.5. So practice those things. Get good at using your calculator because in 11.6, we're going to be doing equations where we have to solve for x. You need to be able to expand, put together, and use your calculator so that you're able to do this, okay? All right. See you later.